On the notes handout that should have been distributed to you, we're going to work through some example problems to help you get prepared for the classwork, the quiz, and the homework assignment, of course. So in number 1, you're just writing the ratios of sine, cosine, and tangent, but in order to do that, you need to know what your hypotenuse is. So we'll call our hypotenuse h, since it's a hypotenuse. So we have h squared is equal to 5 squared plus 9 squared. So this is going to be h squared is equal to 25 plus 81. So this is going to give me h squared is equal to 106. And we take the square root of both sides to have h is equal to the square root of 106. Now you could further simplify that down a little bit, but at this point, we're probably going to end up rationalizing it anyway, so we'll just leave it alone. So when I find sine of theta, then I'm going to end up at here's my theta, opposite over hypotenuse. So I have 9 over the square root of 106. So when I rationalize this denominator, I'm going to have 9 square root of 106 over 106. And then you would reduce this fraction if possible. So theoretically, if I could divide both by 3, then I would reduce it down. If I were to try to reduce 106 and simplify my radical, well, this is going to factor into 2 times 53, and neither one of those can factor down any farther, so it can't be simplified as a radical. So my next trig function is cosine theta, and it's the adjacent over the hypotenuse, and I have to rationalize just like before, so this will be 5 times the square root of 106 over 106. And then my tangent of theta is going to be my opposite over my hypotenuse. Okay, in 2, 3, and 4, you're using the same figure, but you're given different information for the figure each time. So if you take a look at number 3, what they tell you in number 3, and you're solving the triangle, so that means you have to find all the missing pieces. So what they tell us in number 3 is I have this triangle ABC. C is my right angle. They tell me that B is 2.4 centimeters and A is 3.8 centimeters. So that means I need to know my hypotenuse H, the measure of angle A, and the measure of angle B. So to find the measure of angle A, I'm going to take the inverse tangent, since I'm solving for the angle, of the opposite over the adjacent. So 3.8 over 2.4. And then once I know the measure of angle A, then I can find the measure of angle B by simply subtracting that from the measure, or from 90 degrees, since it's a right triangle. And then to find my hypotenuse, I use the Pythagorean theorem. H squared is equal to 3.8 squared plus 2.4 squared, and I solve for H. And that will solve for all of the missing pieces of my right triangle. Now, in number 5 through 8, you are using the point that you've been given and writing the trig ratio for that point. So, and they tell you which trig ratio you're looking for. We're looking for sine of theta. So I'm going to plot this point. Since I'm positive, that means I'm going to be in quadrant 1. And what my point tells me is that my x-coordinate is my horizontal length. My y-coordinate is my vertical length. And my theta lives at the origin. So what you're doing here is you have to find the sine of theta, which means you're going to need to find your hypotenuse again using the Pythagorean theorem. And then once I know my hypotenuse, I can write my ratio sine theta as the opposite, so it'll be 28 over whatever my hypotenuse is. Similar setup for number 6 with cosine. Similar setups for 7 and 8 with cosecant and cotangent. The only difference is that you're dealing with those reciprocal functions instead of dealing with the sine, cosine, and tangent. For number 9, when it says find the exact value, that means don't give a decimal answer. You have to give a simplified radical answer. And what they do is they give you some information about the function. So secant is 7/4. Well, what I know about secant is secant theta is equal to the adjacent side, or the hypotenuse over the adjacent side, because it's the inverse, it's the reciprocal of cosine. And they tell me that theta is in quadrant 4. So what that looks like is this. We have this triangle. Theta lives at the origin in quadrant 4 of my coordinate plane. And if my hypotenuse is 7 and my adjacent side is 4, then in order to find the tangent of theta, I'm going to need to know this side. So we need to know our y value. So we'll have 7 squared equals y squared plus 4 squared, and I'll solve for y. And then once I solve for y, then I can write my tangent ratio as my opposite side y over my adjacent side 4. And in numbers 11 and 12, you are finding the coterminal angle. So in a coterminal angle, it's an angle that's going to share the exact same terminal side. So in number 11, if we look at what this angle is, it's going to be 558 degrees. So if I go around to one time, that gives me 360. And then if I go around to another 180 degrees, that gives me 540, but I'm at 558. So that means my angle is going to exist here. Your coterminal angle is going to be this angle that shares the same terminal side, but goes in the opposite direction. So what I'm going to do is 2 rotations, because this goes a little more than 1.5 rotations around the circle. So I'm going to take 558 and subtract it from 720, because 720 is 2 rotations in degrees around my circle. And that will give me the measure of my reference angle. So 10 minus 8 is 2. And 11 minus 5 is 6, and 6 minus 5 is 1. So my coterminal angle is 162 degrees, which technically is negative because we're moving in the counterclockwise direction. But for 13 through 15, you're just finding the reference angle. So for 13, if I graph this and look at it, 77 degrees is going to be about here. And when you find your reference angle, you need the acute angle that brings you back to the x-axis. So in our case, since we started acute, my reference angle theta is also going to be the same thing. It's going to be that acute angle. And then for number 15, if I graph this one and look at it, well, 383, we're moving in the clockwise direction. And if we go all the way around, that's 360, but we're at 383, so we have to come a little bit more. So this whole angle is 383 degrees. But what I need is my reference angle that brings me back to the x-axis and is acute. So I'm going to subtract 360 from 383. So this is going to give me 23 degrees for my reference angle.